The integral of x log x is done by parts, and we have a product of two functions which is characteristic of all integrals which we attempt to do by parts. Now the formula for the integration by parts is the integral of u dv equals uv minus the integral of v du. In this situation we define the u term as log x, because although we can differentiate log x, we don't know how to integrate it. So we let u equal to log x, so du will be 1 over x, and then the dv must be the x part of that, so v will be a half x squared. I'll put those to one side. Now that means that when we substitute in the formula, we get our original integral, which is x log x dx, is equal to u v, which is a half x squared log x, minus the integral of v du, which is a half x squared times 1 over x dx, which is a half x squared log x minus the integral half times the integral of dx. Taking the constant outside is often a good idea because it exposes just the power of x that we're interested in. So I'm then left with a half x squared log x minus a quarter x squared plus the constant of integration. Now these integrals by parts are straightforward. The one thing you've got to be careful of is that you write this down and use that to substitute into the actual formula. And what some people do, they do relate these in this way to make sure that you can see which way that you're doing the substitution. But this is the best way I've always found, that people then get through to the bottom without having major problems.